So I will be answering the following conceptual questions in the back of this worksheet. The first one states that, according to legend, a horse learned Newton's laws. When the horse was told to pull a cart, it refused, saying that if it pulled the cart forward, according to Newton's third law, there would be an equal force backwards. Thus, there would be balanced forces, and according to Newton's second law, the cart wouldn't accelerate. How would you reason with this horse? Well, so a horse knew Newton's laws, and it was pulling a cart. He knew Newton's laws. Because of his knowledge of Newton's laws, he refused to pull the cart because of the third law, which stated that there would be balanced forces if he did, thus the cart wouldn't accelerate. So he knew that, and because of that, there would be an equal balance of the second law. So if he pulled, the cart would have an equal balance backwards, and it would pull back. So the horse would go backwards, the cart would move forward, canceling out like any movement of acceleration because of the two forces, and because these are both unbalanced like objects. But we can prove the horse wrong because the horse would be able to move itself and the cart forward because the horse is on ground. And therefore, when he's moving forward, he's creating a frictional force, thus allowing it to move itself and the cart forward. Now I will answer the second question on this worksheet, which states, an accelerometer is a device that measures acceleration. A basic accelerometer is nothing more than a jar filled with water and a cork suspended in the water. When the jar is moved, the cork points to the direction of the acceleration. How does this type of accelerometer work? Well, this is what it looks like. So it's basically a jar of water and a cork like this, holding it down, and it's floating. The cork is floating. And then this is an example of an accelerometer, but how does this type of accelerometer work? Because of inertia. Inertia is basically the resistance of any physical object because of their mass, or basically like their density on whatever object they are on. So this type of accelerometer works because of inertia, because of the mass of the two objects, the inertia of the mass of the two objects. In this case, since the water has a higher density than the cork, it is most likely to stay in a more stable position than the cork. Therefore, the cork is resisting being moved, but gets surpassed by the force of the water, moving it towards the water's motion. So, the cork is definitely less dense has a less of a mass than the water does, and the water just happens to stay more stable than the cork. The cork is definitely going to resist the motion of the water, but the water, since it's heavier than the cork, it will make it move. So, moving the water that way, the cork is moving that way because the water will be moving it. That's why it follows the direction of the water because of the inertia of the mass, which is the water is heavier than the cork. Now I'm going to answer the third question on the worksheet, which says, a submarine is submerged 50 meters below sea level. Draw the action-reaction pairs in the system. Well, first of all, we need to figure out what an action-reaction is. Action-reaction is like a pair of forces acting on the two interacting objects. The size of the force on the first object equals the size of the force on the second object. The direction of the force on the first object is opposite direction of the force on the second object. So forces come in pairs.